for
What'd you say?
A.
No.
So
A is 1 millimeter.
So that is what? As our variable? Our variable is, that'll be represented by x, right?
Oh, yeah, okay.
X equals, for A it would be 1 millimeter, right?
Right.
So, what's the formula we're going to use?
Your Maurer intensity.
Okay, so it's, you read it out to me? Yep.
Equals IO E negative mu x.
Close.
No, it's
These have rows in them.
Rho over P.
Rho over P.
I'm sorry, mu over rho.
Mu over rho.
But if I have mu equals mu over rho divided by rho.
Okay. But this is the other formula.
Okay.
Right? I see what she's doing. What she's doing is
Getting it back to the original.
She's doing mu over rho times rho equals mu.
Yes.
And then she's taking this and she's plugging it into IO equals that. So she's doing this outside the formula and then plugging it in.
Right.
Just a fine way to do it. I'm going to do it all in one.
So you said.
So again, now we have so first thing we ask ourselves is what do we have? Next thing we ask ourselves is what are we looking for? Third thing we ask ourselves is what formula has all these things and the thing we're looking for, right?
Right.
Then the fourth thing we always ask ourselves is which one of these is not like the other in terms of units,
Okay.
right?
Right.
So which one of these is not like the other?
Millimeters and centimeters.
Yep. So which one do we want to convert? Centimeters to millimeters, or millimeters to centimeters? Obviously, that would be easier because there's only one to convert to centimeters. If you convert these to millimeters, you have to convert both of these, which is a pain in the ass and a waste of time.
So 0.01 centimeter.
So we'll say we want millimeters in the bottom, centimeters in the top, right?
Mm-hmm.
And what's going to be our little ratio here? You can say how many of these are in one of these, or how many of these are in one of these. Which way do you want to look at it?
How many of these are in one of these?
Yeah, that's the right answer, but which one are we talking about?
10 millimeters in a centimeter.
How many, so how many millimeters are in a centimeter? 10 millimeters in a centimeter, right?
Mm-hmm.
So what does that equal?
0.1.
0.1 cm. Which makes sense, 1 millimeter is 0.1 cm. You guys know that because out on your OBI you always see, 2.1 cm shift or whatever. That's 2.1. Okay. So that's everything. So now all the units match. Everything should cross off in our exponential when we plug it in. And we will just from here go. I'll say 1 equals E times e to the minus mu over rho is 0.03. That's the whole thing. That's the mu over rho together. The rho is 3. Your x is 0.1. Right? This often confuses people because it's this mu over rho thing, but it's telling you that mu over rho equals 0.03. You don't have to do anything with it. Now, another double check that I like to do is I like to just put in the units and see if they all cross off. So you could say this, let's just say, this would be 1 e to the minus, what would be the units of mu over rho?
Cm squared over g. Right.
Cm squared over g. What are the units of rho?
Gram over cm cubed.
And what are the units of x?
Cm over 1.
Cm over 1 or cm, right? So now we can see here we have 2 of these knocks this down to 1, so you just have cm. 1 of this crosses that off, g's cross off. Everything cancels, right? You just have a 1 in the bottom, which is fine. So you know that it all works out. Don't forget your negative when you actually do e to the whatever that number is, and then you'll be left with the fraction.
Did you get 99.1%? Or I guess you would be 0.99. Okay.
Okay, so B, C, and C are basically the same thing, except it's a little bit easier because you don't have to convert anything. They give you the length in cm. They give you everything else in cm. So you just plug it in.
0.97, 97%. Yes, you're right.
Okay. Simple enough.
Fair enough.
So let's do 4D now. calculate the half value layer of the beam in that
So
material.
half value layer equals 0.693 over mu.
But we
Point.
don't have mu, we have mu over rho.
Uh-huh.
So we can just
So let's slow down here. I'm going to do this the quick way and the long way.
okay.
We have here, it's asking for the half value layer. So, okay, let's start. What's all the stuff that we have? We have mu over rho equals 0.03. I don't know why I erased this because I'm just rewriting it. Rho equals equals 3.0 grams per cm cubed. Makes sense. Now, what else do we have? That's it, right?
We have our
Okay.
thicknesses and we want to know our
And then
half
what are we looking for?
half value layer.
So HVL is what we're looking for, equals in what units?
Centimeters.
Centimeters would be the easiest to do because everything else is in cm. And then we just say, what was the formula that
So
we
I
were
had the
using?
formula HVL equals 0.693 over
HVL equals 0.693 over.
mu.
So, what is mu?
I have 0.09, but I don't really show my units, so I'm not really sure where I got that from.
Well, this is mu over rho. This is rho. Can't we just do mu over rho times rho
Mm-hmm.
equals mu,
Mm-hmm.
right? 0.03 times 3,
0.09.
0.09.
That's where you got it.
Does that make sense?
Mm-hmm. I wish I'd written it out right.
Or you could change, so that's one way to do it, is you change what you have in order to get what you need in your formula. Or you change your formula. You could say HVL equals 0.693 mu over rho times rho. Which in case would be the same thing because you're just adding something and dividing by the same thing. So this is the quick way to do it. I know Andrea likes this equation. She's memorized it, which is good for her. I don't memorize stuff because I'm very bad at it. I have a bad memory.
Did you guys get 7.7 centimeters?
Yep.
So the way I do it is, this is the long way to do it. This is the way I always do it. I say HVL is physically what it means is the thickness of material that you need in order to reduce your intensity to half.
Uh-huh.
So we have IO equals 1, I equals 0.5 then, because by definition that's what we're doing. So now I can use my other formula, I could say so it's I equals IO e to the minus mu over rho x. I say 0.5 equals 1 e to the minus 0.033, x in this case is what we're looking for, right?
Mhm.
X would be my HVL. I can then rewrite this. I can divide both sides by 1, right, to get rid of that thing. Then I take the ln of both sides because this trick is always
Right.
fun to do.
Mm-hmm.
When we do that, we get ln of 0.5 equals just the exponent, right?
Mm-hmm.
I can divide this side by negative 0.03 n3 at the same time, divide this side by negative 0.03 n3 at the same time. This crosses off, I just get x equals this. X is what? X is my HVL. So HVL equals ln of 0.5 over negative 0.03 times 3, which lo and behold is the same thing as 0.96 over mu, because this is what? Mu over rho, this is mu, this is 0.693. See how it all
Same
works
thing.
out? It's all the same thing.
Amazing. I wish I liked math when I was younger.
Fair enough?
Fair enough.
Alright. Number 5. This was a fun one.